Hi guys, so this is the other lesson for this week. It's taking the square root of a function. So I'm going to give you an equation and then you have to square root that function. Ultimately, what I can tell you about this is that when you take the square root of any function, you're literally just keeping the x's and taking their y's and square rooting them. That's it. And then redrawing the point. Okay? So an example up here, there's a graph. This is the equation of y equals 2x plus 1. Do you see it right here? Y equals 2x plus 1. Now, all of these y values on the y equals 2x plus 1 went away when I took the square root of it. Why? Because when I square root any negative y values, they're gone. So these are going to go away on the radical graph. When I square root 0, it stays the same. When I square root 1, it stays the same. And then I square root all the y values in between. So if I go to where y was 4, which is here, it's now going to be that same x value, but it's going to be at 2. And we get this lovely graph here, okay? Where all we're doing is we're keeping the x values of the original and square rooting all their y's. So wherever y's are negative, you're going to have no graph, all right? So here, we're going to compare one. So here it says, compare the graphs of linear functions. And you can read the top. It gives you a summary at the end. You can read that very front box at the very end if you'd like. So compare graphs of linear functions and square roots of the function. So we're taking any function, mainly linear and quadratic, and then we're square rooting them, okay? So if I just go and I type into my calculator, let's see here. Boom. So into my calculator, I'm typing 4x minus 3. So you're typing 4x minus 3. This is impossible. Okay, I'm not going to do it. Type into your y equals 4x minus 3, okay? Hello. Hi, you all. This is me, being cool. I will never do this again because, well, you can see I look awesome. But because it's our first week, I thought, you know what? I can be a goof and I can look ridiculous. And wow, look at that wall. Welcome to my basement suite. Right? Right. Okay. Just so you know, still in a basement suite. House is not done. Right? Right. I will let you know when it is, though. Miss you all. Okay, so we're back. Can you type that into your calculator, into the 4x minus 3? Or if you don't want to type it into your calculator, you could literally just plug these values here into this equation and get your new y, right? That's what the calculator does every single time you type that in. But because I don't want you to listen to me for 80 years, because who ain't got time for that, right? I'm going to type them in off of my calculator. So if I type in 0, I get negative 3. Now remember, if you have 0.75, you can't get directly off your table, but remember I showed you, you could go second, trace, value, and then you can put in any x equals you would like. And yes, I'm in my bedroom because it's the only quiet place from my children. So, exciting, right? Okay, so you're going to type that in. So you're going to go second, trace, value, 0.75. And you're going to get a 0. And then you're going to go second, trace, value, 0.8. And you get 0.2. And then second trace value 1, or you can go back to the table. And at 1, it's at 1. At 2, it's at 5. At 3, it's at 9. At 5, it's at 17, which is probably off of this lovely graph. Okay? Now, we can plot those points. Okay, we're going to plot them. Oh, 17 is on this graph. I'm so smart when I made these notes. Okay, so we're going to go 0 and -3, and the blue graph is going to be the y equals 4x minus 3. So 0 and -3, 0.75 and 0, 0.8 and 0.2. Well, that's really close. 1 and 1, 2 and 5, 3 and 9, and 5 and 17. Could have put the 4 in there as well. Oops, 5 and 17. Okay, so we connect these. Ooh, my goodness. That's supposed to be a straight line. Can you please draw a straight line? Because, well, that's not. Okay. So what we're then doing to draw the radical of the graph is you could type that into your calculator. You could type in square root 4x minus 3. But what we're actually doing is we're keeping these x values. So I want to make this red so you can see. We're keeping all of these x values. And to get our new y values, we're just square rooting our old y values. Okay? So you could type this into your calculator, y equals square root 4x minus 3, and draw it. But what we're actually doing is we're just square rooting our y values. So if I square root -3, I'm actually going to get nothing. Does not exist. Because you can't square root a negative number. If I square root 0, I get 0. So that's where my graph is going to start, is at the square root of 0. So wherever the square root of 0 is, that's where my new radical is going to start. And this blue isn't going to actually exist. Okay, so I'm at 0 and does not exist, so I can't draw that one. Then I'm at 0.75 and 0. That's my new point. And then I have to take the square root of 0.2 to get my new y value. The square root of 0.2 is 0.44. 45, I guess. Doesn't matter. It's not going to change how I'm going to graph it. Now my new point's at 0.2 and 0.45. I mean 0.8, sorry, not 0.2. 0.8. We use these x values over here. 0.8 and 0.45. Oh my gosh, this is going to be hard to draw. And then I'm going to use the square root of 1 because I square root that one, which is 1. So my new point is at this x, which is 1, and my new y, which is 1. So it actually stayed the same. Why would it stay the same? It would remain invariant whenever your y equals 0 or your y equals 1, because when you take the square root of those y's, they're the same number, so the point won't change. So you have invariant points when y equals 1 and y equals 0, because your points won't change. Then I'd have to do square root of 5, which is some crazy decimal, 2 point something. 2.2. So my new point's at 2 and 2.2, not 2 and 5, but 2 and 2.2. So the x's stay the same, and you square root the y's of the original. So 2 and 2.2. And then square root of 9, which is a nice one, so 3. So my new point's at 3 and 3. 3's are not getting any better for me, it seems. 3 and 3. And then square root of 17, which is 4 point something, 4.1. I'm going to get 5 and 4.1 because the x doesn't change, only the square root of the y's. So 5 and 4.1. And there's my new radical graph when I took the square root of all those y's. See? So the domain only exists on the radical where the original graph is above the x-axis, because all the y values below the x-axis are going to go away, because when you square root negative y's, they don't exist. Okay? Next page. So determine the points of intersection. The points of intersection on the previous page are our invariant points. So they're the points that do not change. So that's going to be at 0.75 and 0 and 1 and 1. Because they're the invariant points. They're the ones that don't change, because if I square root 0 or square root 1, I get 0 and 1. How is the x-intercept of the graphs of f of x equals 4x minus 3 related to the graph of y equals square root 4x minus 3? They're the same, because x-intercepts are when y equals 0, and we're square rooting all our y's. And when we square root 0, it stays 0. So they are the same. Why are the points of intersection referred to as invariant points? Because, I'm starting a sentence with because, that's terrible. Because the points do not change. Because remember, you're keeping your x's and you're rooting your y's to get your new points, right? So my old point is 0.75 and 0. And my new point on the square root x graph is going to be 0.75, keep my x, and then I square root 0. Well, what the heck's that? The same thing. These are equal. And my other one is 1, 1. That's on my original. It's going to become, keep my x, root my y. Root 1. What are those? They are equal. Equal, so they're invariant. They do not change. Okay. Find the domain and range for y equals square root x squared plus x minus 5 and square root x squared plus x minus 5. So I'm going to just sketch that original one by plugging it into my calculator. So I'm going to go into my y equals, and I'm going to type in x squared plus x minus 5. Now what I need from that graph is I need its min or max. Okay? If it's a linear, you can just draw the whole thing. If it's a quadratic, you need its min or its max. In this case, it's a min because it's concave down. So I have a minimum, and I can find it with my calculator. I have a minimum at negative 0.5, comma, negative 5.25. So negative 0.5, negative 0.5, and negative 5.25. So approximately there. So I need my minimum or my maximum, and I need my x-intercepts. And then I can put in other points as well, but these are the needed points that I need to sketch when I'm sketching this original one. So my x-intercepts, I can use my calculator to find them as well, the way that we went through in class. If you can't remember, message me and I will help you. So the first x-intercept is at negative 2.79 approximately, and 0. Okay, well, we're rounding. So instead of rounding, maybe we should just figure out what they are. How can we figure them out? If they're not nice like that, quadratic formula. So I'm going to go x equals negative b, so this is my a, this is my b, this is my c. So my a is 1, my b is 1, and my c is negative 5. So I'm going to get x equals negative b, so negative a positive 1, plus or minus the square root of b squared, so 1 squared, minus 4 times a times c. It's a 5. Oh my goodness. It's getting worse. It's getting worse. Minus 5 all over 2 times 1. So I'm going to get x equals negative 1 plus or minus. Now this is going to be negative 4 times 1 times negative 5 is positive 20, plus 1 is the square root of 21 over 2. Which we can't reduce the square root of 21. There's no perfect squares that can come out of it. So that's where it's going to sit at. So I'm going to type them in, though, so I can get the approximate ones, okay? So it's approximately 1.79 and negative 2.79, okay? Those are the approximate x-intercepts. So I'm going to plot those as well. So 1.79, try to get in here. So 1.79 is my 1, and negative 2.79 is my other. And then I want some more in between. So I'm going to type it into my y equals. And I'm going to go to my table of values and pull some points off of it. So I have on here negative 4 and 7. 1, 2, 3, 4, 5. Yeah, negative 4 and 7. I have negative 3 and 1. I have negative 2 and negative 3. I have negative 1 and negative 5. I have 0 and negative 5. I have 1 and negative 3. All these negatives are going to go away anyways, though. Then I have 2 and 1. And I have 3 and 7. Okay? Oh, this is going to be fun. I'm going to hope this doesn't turn into a complete disaster. So there's my 1. There's my other. Okay? Now all I'm going to do to find my new graph is I'm going to take those x values, keep them, and root my y's. So when I square root any of the y's down here on this red part, when I square root any of those y's, all those y's are negative. So they're not going to exist on this graph. Okay? When I square root this y, it's going to stay 0. When I square root this one, it's going to stay there too, because square root of y is 0, 0. Square root of 1 is going to stay. So wherever you have y equal to 1 and y equal to 0, I immediately put dots, because those are going to stay. 0.5 is going to become 0.75, so it's going to bump out here. And then I can go to square root 7. So I'm at 3 and 7, right? That's my 1 point. Oh my gosh, I really can't do 3s. 3 and 7. It's going to become 3 and root 7. Okay? 3 and root 7. Root 7 is 2.6. So my new point is going to be at 3, comma, 2.6. So I'm going to plot that one. 3 and 2.6. So somewhere here. And then I have another point over here, which is at negative 4 and 7. It's going to become negative 4 and root 7, which is negative 4 and 2.6. So my graph of my radicals ultimately, well, that's not great. It's going to curve and go out like this somehow. This end isn't very accurate because I have no y values to follow. And then this one's going to go out like that. So let's look at the red one. the original quadratic. That one should be easy for your domain because it's just from last year. The domain is XER for the red function. And my range is y such that y is greater than or equal to my lowest y, which is here, negative 5.25. YR. Okay. Now of the blue graph, all of this bottom part of the red's gone. So my domain starts at the x-intercepts. So my domain is going to be x such that x is less than or equal to negative 2.79. Or, which is a little u, x is greater than or equal to 1.79 XER. Now I'm going to be honest. Normally they want the exact values. So they're going to want this negative 1 minus part. So normally, because you wouldn't want it rounded, you would have x such that x is less than or equal to negative 1 minus the square root of 21 over 2, because that is the same as negative 2.79, or x is greater than or equal to negative 1 plus root 21 over 2 XER. Now the lowest my range goes to on this blue graph is 0 or higher, so that one's easy. Y such that y is greater than or equal to 0. Y, E, R. Okay. Example 3. For each point on this graph of y equals f of x, determine the corresponding point on y equals square root f of x. So these ones round to the answer to the nearest tenth if necessary. Remember, original point. To find the new radical point, you just keep the x, root the y. Oh, the new point's 3, 0. It's invariant. It stays the same when y is 0. This one, negative 5, root 25. Keep our x, root our y. So it's going to become negative 5, 5. This one is 9, root 15. Root 15 is 3 point something. So nearest tenth, it's 3.9. So my new point is going to be at 9, 3.9. Oops, what just happened there? And then this one is going to be at 4, keep my x, root my y. Oopsies. Square root negative 16. What? You can't do the square root of a negative. That is bad. Math ticket. Boom. The point does not exist on y equals square root f of x. You just wouldn't be able to plot a point. Remember, that's one of those y's that are below. Okay. Example 4, you would just graph each of those lines, the line on the first one and the quadratic on the second one, and then you would take the x's, keep them, and root the y's. So any negative y's would go away. You could also just type in, to check your answer, you can type into your calculator square root 3 minus 2x to check it, to see if you got it right. But first you would draw this graph and then square root all of its y's, and then check it with that. Next you would draw this graph, square root all of its y's. Or check it with this when you're done. Okay? The last thing you could be given is the actual graph, not an equation, so you can't type it into your calculator, and you have to find the new graph. So remember what I tell you to do? Keep the x's and square root the y's. So this part is going to go away on the square root function, so is this part. Because when I square root all those y's, they're all negative. They're going to go away. The next thing I do is I bold where y equals 0, which is on the x-axis, and where y equals 1, which is here. Because where y equals 0 and y equals 1, when you square root, you will get 0 and 1. Then I go along to other ones. So this is where y equals 4, right here, right? So that's at 2 point something and 4. So now it's going to be at 2 point something and 2, because the square root of 4 is 2. So it drops down, like it falls down, drops down to 2. And where this is 4, on the left at negative 2 point something, it's now going to be at negative 2 point something and 2. So it's going to drop down here too. So I have those points. And then I go to 0 and 9. 0 and 9 is going to become 0, comma, square root of 9. So my new point's at 0 and 3. Keep my x's, square root my y's. Okay, so this here is the square root of that quadratic. Obviously, it could be drawn a little more accurate. I'm not doing the greatest on the tablet. Okay, let's go to this one. So all of these are going to go away. These are all negative y's. Gonzo. Like here, 0, negative 9. 0, comma, negative 9 is going to become 0, comma, square root of negative 9. Can't square root negative 9. Not going to get a point. So all these y's, where y's are negative, are going to go away. Where y equals 0, it's going to remain invariant because the square root of 0 is 0. Where y is 1, it's going to remain invariant. Okay, then I'm going to go to where y equals 4. So it's at negative 3.5 and 4. So now it's going to be at negative, it's going to drop down to negative 3.5 and 2 because I square rooted its y. This one's going to be negative, positive 3.5 and 4. It's going to drop down to 3.5 and 2. Then I go to where y equals 9, which is here, right? It's at a little bit over negative 4 and 9. It's now going to be at negative 4 point something and 3. This one's at 4 and a little bit and 9, right up here. It's now going to be at 4 and a little bit and 3. So we're going to get this. So the green graph. And these arrows could go up. We need more graph to accurately sketch how this is ending. Okay. But as long as the part that you can see is sketched correctly, that's good. Last thing. Explain why the points where f of x equals 0, f of x is just y, where y equals 0, and f of x equals 1, y equals 1, are always invariant points when graphing the square root of a function. They're always invariant because when you square root 0 or square root 1, they remain. I guess we should say y equals 0 and y equals square root 1. They remain y equals 0 and y equals 1. Remember, invariant means does not change. That's it for today.